So here's a relatively basic example of dimensional analysis. So Newton's second law can be shown to produce the formula the sum of forces is mass times acceleration, where m is in kilograms and a is the change of velocity over time. What is the derived unit for the sum of the forces? So I'll let you have a go yourself at this question, and when you're ready you can unpause the video. Okay, so here is the solution. We've written the sum of forces as mass times acceleration. Acceleration is the change in velocity over time. Now, there should be deltas here because the change of velocity over change in time. However, velocity is meters per second divided by seconds. So that's sort of like writing meters per second times 1 divided by seconds, which gets you this guy, which is meters per second squared. Some people say meters per second, but that gets really, really repetitive, especially if you say it a lot and you stutter easily. It's not very fun. So mass, we're given the units kilograms, so there's kilograms. A we found out as meters per second squared, so our derived unit is kilogram meters per second squared. One key thing to note is that to simplify things, we don't say, say a 5 kilogram block, it's accelerating 1 meter per second squared, so it has a force of 5 kilogram meters per second squared, because that's just way too long and we don't want to deal with that. So we've instead denoted 1 kilogram meter per second squared as a newton. So if a 1 kilogram object, so here we'll have a 1 kilogram object, accelerates at 1 meter per second squared, then a force of 1 newton must be pushing it. So that's sort of a benefit of using the metric system, is that everything usually comes in ones.